this question, Andy and Erica have both graphed two functions that are parabolas. Let's analyze the set of attributes that go with each parabola. So the first attribute says that the domain of the function is the set of all real values. And that's going to be true for both Andy and Erica, as any parabola opening up or down will have a domain that's the set of all real values. The axis of symmetry is x equals -3. Now that's going to work for Andy's graph, because our vertex is at x equals -3. We know that the x value of the vertex is always our axis of symmetry. However, for Erica's graph, the x value of the vertex is at x equals +3. So that's not going to work. So just Andy's graph. The range of the function is y must be greater than or equal to -4. And our lowest point on Andy's graph is -4, and y can be any value above that, so that's going to work. And our lowest point on Erica's graph is also -4, and y can be any value above that as well. So the range for both of them is y must be greater than or equal to -4. A possible equation of the graph is f of x equals x plus 3 all squared minus 4. So I'm going to go to Andy's graph. Its vertex is at -3, -4. And that works for this equation. Erica's graph has a vertex at +3, -4. So this is not going to work. So just Andy's graph. And lastly, compared to the graph of the basic function f of x equals x squared, the point -1, 1 is then shifted to the point 2, -3. So on the basic graph, we have the point -1, 1. And we know that on Erica's graph, everything has been shifted 3 units to the right and 4 units down. So if I went from -1, +1, and I shifted everything over by 3 and down by 4, I would get to the point of +2, -3. So that's going to work on Erica's graph. Clearly that point does not exist on Andy's graph. There's nothing at +2, -3, so that's not going to work. So just Erica. Let's check our answer.